All right, welcome, Gapsters, and thank you so much for joining us today. Today we have the pleasure of hearing from Sergio Morales, who is going to present the topic facilitating NLP tasks with Hugging Faces, Transformers, and vLLM. Sergio has a master's degree in computer science from Instituto Tecnológico de Costa Rica and is a principal data engineer here at Grow Solution Partners, where he has worked for over 10 years. In his career as a data practitioner, he's worked in the field such as molecular biology, astronomy, and natural language processing, and taught data analytics as part of the postgraduate analytics program at Senfotech University here in Costa Rica. He enjoys spending his time with his two dogs, Luna and Lluvia, and playing board games. So join him every Thursday at the Granadilla Hub if you do too. In this talk, Sergio will introduce the concept of transfer learning in the context of machine learning and how it enables software developers to leverage off-the-shelf language models to accomplish NLP tasks with only a few lines of code. So thank you, Sergio, for all the information that you are going to share with us today, and the stage is all yours.
Thank you. Thank you for the wonderful introduction. As Danielle just said, I'm going to be talking about facilitating NLP tasks with Hugging Faces, Transformers, and vLLM. Now, this is an overly complicated title, and what I really mean is what we're going to be doing is we're going to be accomplishing NLP tasks such as summarization or classification or what have you, content generation, mask filling, etc. Tasks that are associated with text in only a few lines of code. So you can get started if you are a software practitioner that necessarily does not have the background for the complex side of LLMs, and all you want to do is you want to start toying around with all of these models and techniques that are now coming out and growing in popularity. We are going to be doing this through the application of a principle that is called transfer learning. Transfer learning is very much like this, which I also shared in the Mind the Gap channel earlier yesterday. Engineers love shortcuts, right? We have been taught to love black boxes and love easy APIs that allow us to get the input that we want to submit and then have an output that we also want to get in response without really caring what's happening in between. And that is kind of a devil's bargain, right? It does enable us to get things done really, really quickly. But at the same time, it often comes with caveats, and it often comes with things that we don't really fully understand that are happening underneath all of that, which is giving us that shortcut. So I'm going to be trying to provide the shortcut so that you are able to accomplish all of these things, while at the same time also commenting on those caveats and also commenting on what you should be aware is happening underneath. So you're not completely lost when it comes to explaining how exactly you're doing what you're doing, right? In this case, I am presenting the unmodified XKCD comic, one of my favorites, which is very, I think it's very funny how this guy just is able to import anti-gravity and start flying, and it's not too far off from what we're about to do. So enjoy. Going back to what I mentioned earlier, the concept of transfer learning, this is really a complex word that can mean very technical things. However, I'm using it in a very generic way, which is we are using a model that was developed for a given, usually general task, and we are reusing it as our starting point for a second model that's going to be specialized in some way on a second task. So, this is a very popular approach in what's called deep learning. So this isn't exclusive to natural language processing, but it's also very much used in voice processing. It is used in computer vision, and other modalities of machine learning that do not necessarily relate to text, where pre-trained models are used again as starting points on tasks, given the vast compute and time resources that are required to develop those models in the first place. So those are usually what we call foundational models or base models. They have very basic knowledge in terms of specific domains, but they are really good at interpreting language and understanding what we're asking them to do or what the input is saying for unstructured text inputs. So in that sense, they are really useful as starting points or as kind of boilerplates for furthering in terms of training and specializing towards a specific direction. And there are several degrees of what transfer learning can actually be. I'm going to be referring to those later on in the presentation. So this is a pictorial representation of what I am talking about in terms of transfer learning. We are going to start with a very, very large data set. And by large data set, what I mean is the entirety of Wikipedia, the entirety of Reddit conversations, the entirety of Twitter, the entirety of all of these publicly available or somewhat publicly available data sets, which have been crawled by gigantic computer resources and have been fed into these models as part of a very long, very compute-intensive training process. And what we've got as a result are very decent models that can understand language. They also come with a lot of biases and prejudices, and they reflect everything that's kind of prescient about society at large, but they're pretty good at interacting with language. And then what we're going to do is we're going to take those models as our starting point. We're going to feed them with smaller domain-specific data sets. They don't have to be, in some cases, longer than a couple of entries. And we're going to fine-tune them so that we get a new model out of them through a process that isn't as heavy or as intensive as the first kind of iterations that produce the base model. And we're going to come up with a new model that's going to be really good at a very specific task. All right. So again, what we're going to do is we're going to take advantage of the fact that engineers can, with very basic coding experience, use this principle to take all of those pre-built models, which are publicly available and they can download and use through packages like transformers and vLLM, which we're going to be talking about today, without, again, having to go through all of that hard and expensive process of training one from scratch, from zero, let's say. Also, an important clarification here, in some of the previous talks during the Data Fest, you've heard people use the word transformers. And this is a little misleading because there is transformers, the technical principle, which is kind of like the technique behind training these models and building these models. What we're going to be talking about today is transformers, the package, which is a Python package that's distinct from the, let's say, theoretical or methodological principle that we call a transformer. So that's a little misleading, but yeah, that's just a quick clarification for you not to be tripped up on that. We're going to start talking about Hugging Face because Hugging Face is the company that provides the Transformers package, and that's the one we're going to be using mostly for today, or at least at the beginning of the presentation. So Hugging Face, which you might have already heard of, is a data science platform and community that helps users build, deploy, and train machine learning models. And again, they are not exclusively focused on text. They also offer solutions for computer vision, voice recognition, and other sort of modalities. But we're going to be focusing on text today. It is often called a GitHub of machine learning, not only because it lets developers share and test their work openly, and it is very open source in that sense, but also because its UI visually looks a lot like GitHub, which works for us because I assume that as developers, we're going to be very familiar with that sort of interfaces, and not only GitHub, but GitLab or whatever version control UI you are familiar with. It's going to look a lot like that, and it's going to allow us to browse through existing projects, both from big corporations and individuals, and all sorts of teams in between, to gather documentation on the data sets that they're working with, on the projects that they're working with, the models they have generated. We're going to find code examples. We're going to find versioning for all of the files and artifacts that are associated with their models. And we're going to be able to spawn off our own projects and leverage them for our purposes. Hugging Face is also known for its Transformers Python library, which, again, a little bit misleading if you don't know all about transformers as a theoretical concept, but it's by far the gold standard in terms of quickly leveraging all of these models that are available on the Hugging Face Model Hub. And this library is focused on simplifying the process of downloading, training, and using machine learning models in different tasks, as we're about to see. So real quickly, this is what the main UI kind of looks like. You can see here that I have chosen the datasets kind of hub. And then we can see here that we've got on the right side of the screen a lot of datasets that are up for use within the Hugging Face hub. You can see some of the providers here. It usually looks the same as it would on a GitHub project, where you've got the user or organization that is providing the dataset, and then the name of the dataset after /. And you can see here that we've got some big providers such as Databricks, Wikipedia, Anthropic, Microsoft, and so on and so forth. And we've also got some smaller teams that are providing all of these data sets that are available for training our own models or refining models. On the left-hand side of the screen, and we're going to be going into this a little bit deeper soon, is all of the tasks that these data sets can focus on, or in the case of models, or of all of the models that are intended for use for specific tasks. And this is a tagging system that's going to become incredibly useful really soon, because that connects directly to the transformers kind of design. So you can see up on the topmost bar how you can switch between models, datasets, spaces, which is something similar to how GitHub does teams, posts, because this is, after all, a community. Documentation, which, by the way, Hugging Face has an excellent documentation, and it's one of the reasons that I highly recommend kind of starting with transformers if you're starting out with LLM solutions and want to toy around with doing NLP tasks in general. So talking a little bit more about transformers now, as I mentioned, it provides access to all of the pre-trained models that are available on the Hugging Face Model Hub to perform tasks, again, on different modalities such as text, vision, audio, etc. This access is granted through APIs that enable downloading and using those pre-trained models on a given text or, again, blip of audio or video or what have you, and fine-tuning them on specific new datasets. Okay, that, again, don't have to be all that big. And you might not even need to fine-tune them if a model is kind of big enough and powerful enough for your purposes. That's all going to depend on a couple of factors that we're going to be talking about later. So going back a little bit to what I mentioned on the previous screenshot, we've got on Hugging Face and transformers the concept of tasks. So tasks are kind of out-of-the-box procedures that can be accomplished with NLP, or rather transformers models. Some of these are very straightforward in the sense that, as soon as you read the description, it's going to become apparent what the model is supposed to do. So we've got things such as question answering, which is something similar to what ChatGPT does a lot of the time, and it might be something that you might want to use if you're building a chatbot that might answer questions about a document, for example. We've got sentence similarity. What you're looking for is trying to establish if two separate fragments of text are similar to each other that may not necessarily share exact words in the way they are phrased. summarization, which is about taking longer fragments of text and making them shorter while retaining the main information that is expressed within. Text classification, if you're trying to classify text into a finite number of categories. Text generation, translation, and so on and so forth. We're going to be visiting a couple of these later on. The very cool thing about these tasks is, as I mentioned, they are part of a tagging system within Hugging Face. And what this allows you to do is I can filter models through all of these methods and select one, go into that specific model, review the associated documentation, see if there are any caveats to its use. For example, some of these may require you have to sign up and then provide an API key when you are actually going to code it out. And another cool thing that Hugging Face offers is all of these models, or rather most of them, offer quick access to the inference API right on their project page. So here I've chosen a zero-shot classification model. And zero-shot refers to the fact that you don't really have to refine this model in order to make it classify between a finite number of categories. What you're going to do is, without providing any example, without providing any more data, you're going to give a fragment of text. In this case, it says, I have a problem with my iPhone that needs to be resolved ASAP. And then I have provided a number of possible class names, or rather not I. This is the default example for this specific Facebook model. And we can see it says urgent, not urgent, phone, tablet, and computer. And what these models are going to do is they're going to give you a likelihood score for each of these classes, each of these 5 classes, of what the likelihood is that the text somehow relates to that class. So we can see that we have clicked on the compute button, and it's produced a 0.999 possibility that this is urgent, possibly because of the ASAP, of the needs to be resolved, possibly because of all of those exclamation points at the end. And then it's given us a 0.995 possibility or likelihood score that this is related to phone, possibly because of the iPhone text. That's pretty straightforward. And we can see that it's received very low scores for all of the other classes that we provided. So we can see how models are going to perform, and we can make tests right on this inference API kind of small UI that is provided to us through the Hugging Face page before we actually get to the coding itself, which again can come real handy for someone that's just starting out and just wants to browse through the available models to see what kind of level of effort they're going to require in order to accomplish their classification task in this case. So just a couple of notes, because as I said, I am going to give you kind of one-liners for all of this stuff, but I do want you to understand what's going on underneath. So real quick, this is inference behind the scenes. Inference is the word that is usually used for just feeding some data into the model and then having the model generate something that is processed as an output. So that is the process of inference. And this is basically what it looks like. We're going to have our input data, which may be a data set that we are we're producing as outputs as a batch, or it may be a single fragment of text and a set of labels like we saw with the previous example. What's going to happen is this input data is going to be tokenized. So if you don't know exactly about how these models work, all you really have to know is within the model that's being fed, again, with these gargantuan data sets, Wikipedia, Reddit posts, Twitter posts, etc. All of these words have been kind of placed into a multi-dimensional representation, and they have been turned into vectors. And this allows the model to be able to measure the distance, basically, between all of these vectors, all of these words, all of these kind of semantic meanings behind the words, and establish how likely it is that they appear together, appear right after each other, appear in the same context or in the same kind of conversation. So what happens is we're going to take that input data and we're going to tokenize it, which is basically taking all of those words, all of those new text that it is seeing, and turning them into vector representations so they can be compared against this representational model that the model has within. Usually, each model has its own tokenizer. There are like standard tokenizers that you can use, but always use your model's tokenizer because that's going to place them within the representational kind of instance that the model can understand. So that's something that's going to happen behind the scenes for us. But if we eventually move on to more complex models, or if we want to do kind of more sophisticated refinement of models or fine-tuning, then that's definitely going to come into play, and that's something you should know is happening behind the scenes nonetheless. And of course, after the model has produced a result, has deemed one of the categories as the most likely one, or has generated new content, or has answered a question, there's going to be a post-processing step through which we're going to actually get human readable outputs, which is, again, the classes that we saw before, or the summary of the text that we were producing, or the translated version of the text, or what have you. The second point that I have is a quick note on resources. You might expect training to be more expensive than inference, and that is true, especially for all of those kind of foundational base models. However, inference can also be very expensive, mostly because holding all of these models in memory is going to require a lot of memory. It's going to require a lot of it. And then we're also going to need a lot of compute resources to get all of those responses back from the model, especially if we're doing batch inference and we've got a big data set that we want to kind of get summaries out of, or classify text out of, or what have you. Usually, cloud services are probably going to be your best bet. All of the usual cloud providers, such as AWS and Azure and GCP, offer their own sort of instances that are GPU-enabled. And you may have heard about having a GPU-enabled instance is kind of a must when it comes to doing efficient training and inference for these kind of models. However, it is possible to run models locally. There are many solutions nowadays for getting your kind of residential computer to run models, especially if they do have a good GPU. All of the GPU vendors, such as NVIDIA especially, they have packages aimed at kind of enabling CUDA resources on all of like their latest graphic cards. So it is possible. You have to consider, of course, the size of the model. There are some models that are just not able to run on these sort of systems. You can also use certain optimizations, and I do recommend the Hugging Face documentation on getting models to run on local systems and small resource environments. They offer things like 4 and 8-bit quantization, which basically means the data that is represented within these vector stores in the model are represented with less bits, as you might expect. It's kind of like encoding numbers in a lesser number of bits, or certain patches and optimizations. As I mentioned, GPU vendor optimizations, which are available for certain families of graphic cards, etc. And of course, given enough hardware resources, if you've got a monster of a computer, then you might be able to run it no problem after all. So with that out of the way, let's get on with our quick start, which is going to be a sentiment analysis example. So this is very popular. Sentiment analysis enables us to figure out whether the nature of the fragment that we provide is positive or negative. And this is something that's kind of been a solved problem for a little while in the field of NLP without having to resort to LLMs. However, this is something that LLMs also are pretty good at. So this is kind of how we're going to begin with our review of the transformers package. We've got a install statement for pip. This is, after all, a Python package. We're going to import the pipeline object from the transformers library in our second line. And then all we're going to have to do is we're going to state the task for which we want that pipeline. And this is pretty cool. We are reusing the tasks that we mentioned before in terms of Hugging Face, the ones that it offers as tags. And we are just instantiating a new pipeline that is able to do that. And I am passing this fragment. I love the Data and AI Fest this year. I hope that's a shared sentiment with you, to this pipeline that I have created. And that's going to return all of the values associated with that text in terms of whether it is a positive statement, whether it is a negative statement, and so on and so forth. And I can pass as many fragments of text as I would like. I can create a loop. I can do batch inference, as I'm going to show later on. And yeah, that's it. You can evidently see how easy this is going to be. Let's change things and try another tag. So let's try for a second example to do text generation. So we're going to give the start of a sentence, and we're going to let the model come up with the rest of the sentence, with what comes after. And you can see that very little has changed from our original example. So you can see that I have, for clarity's sake, changed the name of the pipeline variable. Instead of called sentiment, it's now called generator. I've changed the task that is associated with the pipeline. Instead of sentiment analysis, I've told it I wanted to perform text generation. And well, this line has barely changed, right? It's changed semantically, but it basically is the same thing in terms of I'm using the pipeline variable that I named in the previous step, and I'm providing the input text. So in this case, I said, hello, I'm a software developer, and what it's going to respond with is the rest of the sentence. And I can even pass in through some of the optional parameters that the generator, or rather in this case, pipeline function performs, to give me several alternatives, or to limit its response to a given number of inputs, or to be more or less creative with the temperature parameter that we're going to be seeing in some of the examples below. So here's our third example in which I am specifying a model, because as you can see in these previous examples, I didn't specify a model, and what this means is it's using default models that Hugging Face and the Transformers package maintainers have kind of figured out are decent starting points for all of these tasks. But if you have a specific model in mind that you would like to use, it's just a matter of specifying through the model parameter the name of the model that you want to use. And this name of the model is going to be the same name that we saw in the previous slide, where I showed the screenshot with all of the projects. In that case, it was datasets, but the same applies for the models. If it has a / in its name, meaning it's named after its creator, which again can be an organization or an individual or a team of any size, followed by a / and then the name of the model, then you just copy all of that, paste it into here, and you're going to begin using that model. Of course, as we mentioned, models are going to have different requirements. That is one of the criteria that was used to determine which are the default models. They are generally relatively small. But if you want to go bigger, you can do so by just specifying the name. So why specify a model? Again, we have access to every model in the Hugging Face model hub, which there is a ton of, especially if you drill down to specifics. But as we saw, it also provides generic models for each task. A developer may want to specify another model because it's more adequate for the computing resource available, or it is specialized in a specific domain like medicine or financial tech, or has been trained with a specific dataset. Maybe it is multilingual or language specific. Obviously, if the default models are really good at English tasks, but not so good at Spanish, we might want to switch to a Spanish one so that we can handle that sort of data. This is a little bit more complex in terms of the requirements, but it's not going to be anything new for anyone who knows some Python. So this is text classification, and we're actually doing zero-shot classification. So this is exactly the same as we were doing before with the example of the UI that Hugging Face provides for testing the inference for these models. So in this case, I have created a list of texts, which you can imagine maybe tickets in an IT system. Keyboard not working. I have a candidate for the open position. Is the payroll system getting updated? So on and so forth. And then I have provided a list of labels, such as human resources, finance, and tech support. And I'm trying to get this model. You can see I've placed this string into a model variable. That's mostly because I wanted this to be a one-liner. I didn't want it to overflow into the second line, so that's why I did that. And I want this to try to classify these ticket titles, which I haven't even told it are ticket titles. I just wanted to see if it can relate each of these categories to each of these text appropriately using, again, a classifying kind of methodology. But again, we can see that this is pretty much the same thing as we saw before. In this case, instead of calling the pipeline with just a fragment of text, I've given it both the texts and then the labels that I am interested in it classifying into. And yeah, it's going to classify it for us. So let's see it in practice. I'm going to switch over to my samples tab. And I'm not going to actually be running these because it would take quite a while to get these models into memory. So all of these have been kind of pre-ran, and I'm going to show you the results. This is the same example as I saw before, and I'm going to be sharing this notebook with you all later. So I've expanded a little bit the list of tickets. I've got my keyboard isn't working. I have a candidate to submit to the developer position. When can we expect the next update to the payroll systems? Ergonomic shares will be distributed between senior employees, and what's the expected salary for this position? And again, I want to classify between human resources, finance, and tech support. I'm using that same model that I mentioned earlier, the ND Yugar 3-epoch 3-large, and I'm having it generate the results. As you can see here, for printing, I am kind of pre-printing this, for which I created this for loop. But again, you can see it's nothing weird. I'm just having to navigate through the results a little bit to get at the labels and the corresponding scores for the likelihood of each. But it's not anything that a Python, again, programmer wouldn't be able to get their hands on quite easily. So we can see the results for each of these. I'm going to scroll up. My keyboard isn't working. Got a tech support rating of 0.65, and it's always going to display the top kind of classification first. So tech support for my keyboard isn't working. I have a candidate to submit to the developer position, classified as human resources. When can we expect the next update to the payroll system, classified as finance? Ergonomic shares will be distributed between senior employees, classified as human resources. And what's the expected salary for this position? Kind of a tie, but we can see it's very close between human resources and finance. So I'd say it did quite well. And you can see it took very little in terms of actual effort for anyone with low kind of LLM technicalities knowledge. And you can get started with this sort of tasks today if you have access to an adequate resource. In this instance, I should mention that the resource that I used is this g5.xlarge 4xlarge instance from an EC2 kind of instance provisioned by AWS. This is a Databricks instance that is running on AWS. So again, going back to the presentation, I'm going to be talking a little bit about bias and limitations. And this is a slide that I pretty much copy-pasted in its entirety from the Hugging Face documentation. So I'm not making this up. I actually ran these myself. Be aware, of course, that these models always come with limitations, and models are often trained on all the content researchers can find, for better and worse. So again, some data sources you may consider as being more neutral, such as, again, Wikipedia, for example. Some others, such as Reddit or Twitter, are kind of trash fires, so you don't know what you're going to get. In this case, here's an example, again, copy-pasted from the Hugging Face documentation, in which we're using a fill mask pipeline And again, you can see it's very standard. We're just instantiating the pipeline with the fill mask task on this model, which is, by the way, considered one of the less biased models in Hugging Face, because the training set is considered completely neutral. I think it's trained on Wikipedia and encyclopedias and things like that. And what it's going to do is it's going to give a couple of suggestions on how to finish this sentence and how to finish this second sentence. So it should provide suggestions for man jobs and women work jobs. So let's see how it goes. And it does not go great. We can see that the only response that it's got in common is waiter, if I'm not mistaken. No, this is actually my own output. And on the Hugging Face documentation, it did suggest waiter as a man job, but not in this case. We can see here that we've got nurse, maid, teacher, waitress, and even prostitute for women, which is awful. And this, again, is a neutral model. So again, you have to be very careful about controlling the output of your models, and you have to consider what mechanisms there should be for safeguarding and protection as an integral part of your kind of LLM solution. You can't have it be an afterthought. You can figure it out later. It has to be part of your design. And for this, I do recommend going back and seeing Philippe's webinar earlier on this Data Fest for some tips around that. And this actually hooks into LangChain, which he talked about. So there's a lot to learn with these two kind of talks combined. So everything is compromised. That's good and bad news. There is no such thing as neutral data. As we saw before, this model is supposedly neutral, not so much, especially in the, as society is in the world that we live in. However, NLP models and LLMs and all of these things should just consider another tool at your disposal. Anyone not interested in whether they are enacting or reinforcing systemic harm likely will. LLMs are not. So all you really have to do is care. This is just another way in which you should care for not harming people and not wielding your software prowess irresponsibly. You just have to care for your fellow man, and that is going to be kind of solved if you take the precautions that are required. Let's move on to the second library or package that I wanted to talk about today, which is vLLM. This is a second package, which is kind of a competition of Hugging Face's transformers, or at least let's call it a second backend. It's a little bit more technical, but I think it could also be a very powerful tool to have in your arsenal if you kind of end up getting into LLMs. So this is focused on efficiency and performance. It's compatible with many of the models published on the Hugging Face Hub, so it's not like you lose access to all of those models that we were talking about before. You can instantiate most of those just as well as you can on transformers with vLLM. It can deliver up to 24 times the throughput that Hugging Face transformers can, which is a huge improvement. There is some very cool technical details on how this is accomplished. They have a solution called paged attention that I think they were the first to implement, and it's crazy. It's very, very cool to read about. I do recommend you go read their blog post about it if you are into the kind of technical intricacies. But all you really have to do is you don't really have to change anything about models. You can just instantiate it through these backends, and they're just going to perform better. This is what instantiating a model on vLLM looks. It's not all that difficult. We can see that we are also specifying a model name. In this case, I'm specifying the Ouroboros, which is a instruction-based specialization of another model that's called a Mistral, which is also very good. It's one of the most popular models for content generation and kind of text generation. I'm specifying here GPU memory utilization threshold, and then maximum of the model length, which is, again, kind of a safeguard for the instance type that I'm using, the g5.4x_large that I mentioned earlier. I am also specifying a couple of sampling parameters. So the temperature is something that you're going to come across regardless of what library or package you're using when it comes to LLMs. And it could basically be exchanged for creativity. So it goes from 0 to 1, and it's kind of a determination of how predictable you want your model to be and how much you want it to stick to what it knows, rather than trying to experiment and be creative and try to throw in some word that may within its internal representation not be as close to the ones that it's trying to generate or the ones that it got as reference. So the lower, the more predictable; the higher, the more eccentric and creative. I'm not a fan of using that word, but it's a good quick hand. And then you've got max tokens, which is the maximum number of tokens you wanted to generate. That one's easy enough to understand. And then what we're going to do is we're going to call the generate method on our LLM. Here are some skincare tips as my input, and then I'm providing the sampling parameters that I specified before. So that's going to give me an output that's going to correspond to that. That's easy enough. One of the things that vLLM enables for us is batched inference. So this is possible with a bunch of backends. Again, this is compatible with LangChain, and LangChain is also designed to do this. However, with batch processing, what you are able to do is you can take a large amount of input data, let's say a data set that you have collected yourself or provisioned from somewhere else. And what you're going to do is you're going to take advantage of having several GPU cores and create different instances of your model so they can parallelize the work and finish sooner, which is going to mean paying less for that instance you're running in the time that it takes to produce those results. And that's going to result in your output, which may be predictions or can be any kind of thing, a summary, a translation, a classification, what have you. Here's a very quick template for what batched prompting in vLLM can look like. This I'm using here, this template up here, I can't go into details, but this is one of the templating kind of standards that exist for vLLMs. So usually what we want to feed into the LLM is a system prompt, and then an actual query or prompt that is given by the user so that the vLLM kind of has some context about what the task is we want it to perform. So I'm giving it some information here. It says, you are a classification bot that classifies ticket descriptions as being related to HR, IT, or finances. Reply only with one of those three terms. And that's kind of like the general system prompt that I am feeding this model with. This model, Ouroboros, the one that I mentioned before, is very good at following instructions. So if you're trying to build something that does that, I do recommend you start with it. And then what I'm feeding it is the ticket description, which I'm going to replace with my actual input. And then I'm giving it kind of like the prompt to continue with the classification. And of course, you can be way more thorough than this. I made it as short as I could to make it fit this slide. But we're going to see an example shortly in which template is going to be longer. We can also see here that I'm doing kind of zero-shot classification, except where I'm using a generation LLM for it. So again, you can see I'm giving it classes, and I'm only giving it the description and expecting a classification out of it. We can do more than zero-shot classification, and that's actually something we're going to do in a bit. So in this case, I'm creating a function in which what I'm going to do is give it several values. We can imagine these values input is going to be our set of tickets. I'm going to give it a template, and then I'm going to feed it the LLM that we instantiated earlier. And what I'm going to do is I'm going to create longer prompts, basically, by replacing this input here that I specified within my template text with each value within the values input. And then I'm going to generate with all of the prompts. You can see that this is a list, and this is going to automatically do that batched inference for us. And in the end, we can just return the outputs. You can see here I'm again, navigating into the results so that it only outputs the text that I'm interested in, the final classifications. But yeah, that's basically it. It's, again, very straightforward and nothing you haven't seen if you are familiar with Python. Here is, again, a very quick example on how this would look on LangChain. Again, vLLM is compatible with LangChain. There is a vLLM sub module within the LangChain community package in Python. So you could very easily do the same thing I just did on a LangChain solution. You can see here I am generating a new model, and I'm giving it basically the same inputs that I gave on the kind of native implementation. I am giving to truth remote code parameter as true because that is required as part of the vLLM. I just saw that in the vLLM documentation, or rather this submodule documentation. So just so you know, you have to pass in that bit so that it can download the model. And then you can just invoke it, and it's going to return the same as it would on any other LangChain model or any other LangChain managed model. So again, let's see this in practice. And I do have a lot more examples, or at least a couple more examples for this. Again, do not forget to install vLLM. This is going to take a while. And then this is probably our easiest input here, our easiest example. So I'm, again, importing the LLM object from vLLM. And I'm, oh, give me a second. I'm not sharing the tab. Here we go. And I'm giving it the prompt, hello, my name is, and the capital of France is, which are going to be my sample prompts. I am instantiating this model, the Vicuna 7B, and I'm having it generate response to these prompts. And I'm going to print the output. So you can see it's going to output a whole lot of things. And these are some user warnings and widgets that usually would show the progress of the model being downloaded. But at the very end, we can find our outputs, which again is a little verbose, but we can find the answers easy enough. We can see the prompt here, the original prompt that we gave it is, hello, my name is. And then we can see the generated text here. It says, Dustin Nelson, and I am a senior at Dublin Kaufman High School. Which is very funny. I don't know why it exactly is outputting that, but we did give a very generic prompt. For the second prompt, the capital of France is, it output Paris, but it located at 1600 Pembina. Again, no idea what it is outputting that. Again, we gave it a very generic prompt. And this is a kind of not as high performant model, but again, it kind of generated text as we would expect it to do. Here is a second example in which we are switching to Ouroboros, the one that I mentioned earlier as being very good at following instructions, and I'm giving it 2 prompts. In this case, is here are some tips for taking care of your skin, and to cook this recipe, we will need. So I would expect it to follow this up with a list of tips on skincare, and then a list of ingredients. Here we've got our sampling parameters. I'm providing the prompts alongside with the parameters, and then I'm also doing a little bit of work to get the text out of there, so these are easier to read. So we scroll down, and we can see the results. Here are some tips for taking care of your skin. Protect your skin from the sun. Yeah, that's fair enough. And then to cook this recipe, we'll need, it says 7 ingredients, leeks, cayenne pepper, and salt. And what's happening here also is probably I'm giving it to a few maximum tokens, so it's not giving me very verbose instructions. We can see here that I am generating this further, and what probably happened here actually is I modified the maximum tokens to be higher, and then rerun it again, and we can see that now it's giving me more thorough responses. So the output for the first prompt, here are some tips for taking care of your skin, are cleanse your skin regularly, exfoliate, moisturize, and then it's giving me a short explanation of each. And then for the second one, to cook this recipe, we'll need, it's giving me 10 ingredients. And then it's listing what seems like 10 ingredients. I don't know what this would result. It seems like some sort of sauce or stew or soup. But yeah, we've got it generating results for us in, again, relatively few lines of code. This is the last example for today, and it's going to be a more kind of involved one. So I've got a template, as I showed in the last example in the slides that I was describing. And I'm creating a helpful assistant who converts long-form board game descriptions into a short standardized format. So what I have done is I have gone to Board Game Geek, which is a website which kind of lists board games and board game descriptions and kind of publisher descriptions for each game. And what I've done is I have extracted some of the main paragraphs out of 10 or so board games. So you can see that I've given, again, this system prompt, telling it is a helpful assistant who converts board game descriptions into a short standardized format. And then I'm giving it more of a more thorough prompt for each of the descriptions that I'm going to feed it. So it says the following short paragraph describing board games, themes, and mechanics. Following each record is a single sentence describing the theme and discernible gameplay mechanics. So this is actually not zero-shot classification. This is few-shot classification or multi-shot classification, in which what I'm giving it are some examples so that it has an idea of what it wants, of what I want it to return. And then I'm giving it the actual input. So, you know, it has some idea of what the format I'm looking for is. So for the first example, it says, Earthbound Rangers is a customizable cooperative card game set in the wilderness of the far future. You take on the role of a ranger, a protector of the mountain body you call home, a vast wilderness transformed by monumental feats of science and technology devised to save the Earth from destruction long ago. And we can see here from what this says, from this description, it says that the mechanics are that it is cooperative and involves cards, and the themes are wilderness and conservationism. For the second example, it says, Ostia is a strategy game for 1 to 4 players. Players lead a large fleet to explore the ocean, trade, and develop the port. Make good use of the Mancala system to strengthen your personal board and aim for the highest honor. Description, it says that the mechanics are strategy, trading, and Mancala, and the themes are ocean exploration. So I typed all of these. These are examples provided by me. And what I'm going to do is I'm going to have it generate outputs that look like this. For a whole bunch of other games. So following the examples above, provide a description of the following. And again, what I have created here is a simple function that's going to take all of the descriptions that come, you know, may come from a data set, may come from a list, may come from wherever. And it's going to fit it individually into the LLM using this whole prompt. So each of these examples is going to come with these 2 examples inside. Yeah, I'm going to call the generate once all of these prompts have been generated. And then I'm going to extract. Again, this is just navigating the results so that I can get the text that I actually care about. And since I am feeding it a data frame, I'm going to put all of those results into a new outputs column. So here are my descriptions, and you can see I, again, just created a quick list. I didn't even crawl the website. I just copy-pasted it from a couple of games. So I've got Column Haven, Pirates Cove. I don't know what the name of this game is. ISS Vanguard, Ark Nova, some The Witcher board game, and so on and so forth. I've got a bunch of these. It's like 10. And then I just created a very simple list of descriptions. And then I'm going to call the create descriptions function with the data set that I just created, the template, and the LLM that I instantiated. And then I'm going to display it using the native Databricks function to display tables because it's going to make it look nicer. And this is our result. So let's see, the zoom in doesn't display as nicely as I would like, but you can see here what the original description is. And you can see on the right hand each result that my code has generated. So we can actually kind of figure out if the mechanics and themes that it extracted out of every description seem sensical. So let's try with this Witcher game. So it says, take on the role of Geralt, Jennifer, Ciri, Vesemir, or Dandelion and retell the iconic stories from the saga. Use your unique abilities and follow the path of destiny or completely change its course. The action taken by the group will determine how the story ends, but only one of you will be remembered as a hero. And then on the mechanics, it says role-playing and storytelling, and themes, it says The Witcher and fantasy. This is funny because the original description does not even say The Witcher anywhere, and it still kind of recognize the character names of those coming from The Witcher. That's pretty cool. Let's choose another one. There's this. In the ancient world, civilizations are built upon three foundations: commerce, construction, and expansion. As a leader of an ancient Mediterranean power, each player will need to master all three roads to power in order to lead their civilization to dominance and victory. Oh, this is Mare Nostrum. It's all about the expansion of one's land, the construction of new cities, and dispatching of caravans. And we can see here that the mechanics that it kind of deduced out of that, or inferred out of that description, is strategy, trade, and construction. And the themes is, are ancient Mediterranean, expansion, and commerce. So this seems to have done quite well. And you can see that all I had to provide was a couple of examples of how I kind of wanted the outputs to look like. And it kind of got the right idea in terms of format. This is even surprisingly parsable for a more deterministic kind of input. So we can turn very unstructured text descriptions into something that may eventually end up going into a tagging system or a search engine, or figuring out what games are like other games. This kind of very immediately useful, and I would actually like to see this expanded in separate directions. I could see it going some other places. And this is the example that I showed you before regarding limitations and bias. And you can see I ran it myself, and those were the results that I got. So yeah, even today, these are the results that you're going to get if you don't place any safeguards around these sort of executions and models. That's about it for me. I don't know how much time we have for questions, but this slide is here, so you might as well ask some.
Great. Thank you, Sergio. Yeah, we have time for maybe one question, if anyone has. All right, Emma, go ahead.
Hi. Yeah, sure. Well, first, thank you, Sergio. This is really cool. And it is great. So we can start now more about this kind of tools. They can become even an opportunity for one for clients. Who knows, right? There could be like different ways to use this. Also, I agree with what you said before. Despite the big complexity that is behind the scenes, right? The way to use it is kind of simple, right? As you show it. So this
Yeah,
is really
absolutely.
nice. And I have a question just for curiosity. I don't know if you know it, but do you know what amount of tokens are used by ChatGPT or similar tools? I imagine is really high, right?
Yes, it's really high, and I don't actually know the number. I do know that it is modified like version to version because, and it's also kind of dependent on how much it is able to hold its own context. So one of the things that these companies worry about is kind of, as conversations go on, it kind of starts forgetting about the things that were said a long time ago or several messages ago. So part of the kind of incremental innovation that occurs around these models that are, again, as Philippe said in his talk, I believe, are more incremental than innovative. It's more about increasing resources and being able to increase memory and being able to increase context and being able to increase tokens, etc. Are about. So all of those versions kind of focus on those sort of improvements.
Awesome. Thanks.
All right. Thank you, Sergio, for all this information, all this knowledge that you shared with us today. We really appreciate also all the Gapster that joined for today's talk and attended this presentation. And remember, we invited all of you tomorrow for our next talk. Tomorrow at 8 p.m. Central Time, 7 p.m. Costa Rica time. We'll have a talk title, A Gentle Introduction to Data Science, presented by a former Gapster. It's Carlos Fernandez. He had an internship in Spotify, and he's now located in Hong Kong. That's why it's at this time. So we hope for all of you to join tomorrow, 8 p.m. Central Time, 7 p.m. Costa Rica time. And also, we want to hear your feedback so we can improve our events. So we'll share a link in the chat. So it will be great if you could fill out the form that was just sent. And yeah, that's it for today. Thank you all and have a great day.